Hello everyone. In this video, I'll be talking about frequency distributions and their graphs. The objectives: how to construct a frequency distribution, including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries. How to construct frequency histograms, frequency polygons, relative frequency histograms, and ogives. Frequency distribution. So there's a definition of frequency distribution. It is a table that shows classes or intervals of data with a count of the number of entries in each class. So the example, we have first column class, we have 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30. Then frequency abbreviated as small letter f, 5868854. So that's an example of a frequency distribution. The frequency, small letter f, of a class is the number of data entries in the class. So that means for 1 to 5 class, there are 5 data that belong to this class. For 6 to 10, there are 8 data that belong to this class. For 11 to 15, there are 6 data that belong to this class. So forth and so on up to 26 to 30. There are 4 data that belong to this class. Each class has a lower class limit, which is the least number that can belong to the class, and an upper class limit, which is the greatest number that can belong to the class. So if you look at the given class distribution, so we have 1 to 5, 6 to 10, up to 26 to 30. So 1 is the lower class limit, 5 is the upper class limit. 26 to 30, 26 is the lower class limit, 30 is the upper class limit. So all of these numbers in here are what we call the lower class limits, and all the numbers in this column are what we call the upper class limits. We have also the term class width. The class width is the distance between lower or upper limits of consecutive classes. So for example, we have here 6 and 1. The difference is 5. And this difference is what we call the class width. 10 and 5. So 10 minus 5 will give you 5 also. Then we have 11 minus 6, 5. 15 minus 10, 5. 11 minus 16 minus 11, 5. 20 minus 15, 5. 21 minus 16, 5. 25 minus 25. 26 minus 21, 5 also. Then 30 minus 25 is equal to 5. Or in general, when we talk about class limit, that refers to the difference between any 2 consecutive lower class limits, or the difference between any 2 consecutive upper limits. So if you look at any 2 consecutive lower class limits or upper class limits. So if we take 25 and 30, the difference is 5. If we look at these 2 as consecutive lower limits, so we have 16 minus 11 will give you 5. The difference between the maximum and minimum data entries is called the range. That is, the maximum minus the minimum values would classify as the value of the range. So constructing a frequency distribution, how are we going to construct frequency distribution table? So number 1, decide on the number of classes. So usually between 5 and 20. Otherwise, it may be difficult to detect any patterns. So usually between 5 and 20. But if we're going to look at other authors in assessment of learning, other books in statistics, there are what we call other ideal number of classes. But in this case, according to the author, according to Dr. Larson of Person Product Education, the ideal one is usually 5 and 20, between 5 and 20. Find the class width. So determine the range of the data. So range is equal to maximum minus minimum, or the highest minus the lowest one. Divide the range by the number of classes. So take note, the ideal number of classes is usually between 5 and 20. Round up to the next convenient number. So round up to the next convenient number. So we don't actually follow the law of rounding off numbers, but we're going to say round up to the next convenient number. Find the class limits. You can use the minimum data entry as the lower limit of the first class. So you can use the minimum data entry or the lowest value found in the data set as the lower limit of the first class. Then find the remaining lower limits, add the class width to the lower limit of the preceding class. Take note that in the previous slide, I mentioned already about class width. Find the upper limit of the first class. Remember that classes cannot overlap. So there is no overlapping between classes. Find the remaining class upper class limits. Make a tally mark for each data entry in the row of the appropriate class. So go over the row data. Then you are going to tally each of those datum found in the set as to where it belongs. So what kind of class does it belong to? 5, count the tally marks to find the total frequency for each class. So here's an example. The data set lists the out-of-pocket prescription medicine expenses in dollars for 30 U.S. adults in a recent year. Construct a frequency distribution that has 7 classes. So the data are adopted from Health United States in 2015. So we have 200, then down to 300, up to 342. So let's count the total number of data. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 columns times 3 rows, that's 30. No? 30. So from the given, we're going to decide on the number of classes, so 7. So in our case, so that all of us will have a uniform number of classes, then I will be the one to set the number of classes. But in actual practice, you will be the one to do it. So in this case, our number of classes is 7. Number 2, find the class width. So how are we going to find the class width? So we have range divided by the number of classes. So range is equal to maximum value minus the minimum value, then divided by the number of classes. So if you look at the data, the maximum is 405. So look at the data. The highest one is 405. The lowest one is 155. The number of classes is 7. So we have 405 minus 155, so 250 divided by 7. So that's approximately 35.71. Remember that if the division is not exact, you're going to use the symbol for approximation. So approximately 35.71. Okay. So if you're going to look at, let me go back here. So 35.71. So we normally round off this one to the next convenient number. So that's actually the higher one. So that's 36. But if, shall we say it's 35.2, still the next whole number, not actually following the law of rounding off numbers. Whatever decimal that you have in there, round off that one to the next whole number. So the third one, use 155 as the minimum one. So if you look at the lowest one is 155. So we have 155, the minimum value, as the first lower limit. So we have 155. So 155 as the first lower limit. Add the class weight. So you know the class weight is 36. From our previous computation, it's 36. So plus 36. So 155 plus 36, 191. And this is the lower limit. And we are going to find the upper limit in here. So before 191, so it is actually 190. Okay? So we plus 36 to 155 plus also 36 to 190. So 190 plus 36 to 226. So again, we start with the lowest value. That's the minimum value found in the data set given. So 155. Then we add the class weight. The class weight is actually the one that we have calculated in step number 2. It's 36. So we have plus 36. So we have 191. But in here, we don't know yet the upper limit. But we know before 191, it's 190. So our first class, we have 155 to 190. We add 136 to this lower limit. So we add also 36 to this upper limit to have a balance between what we do in the lower limit and what we do in the upper limit. So plus 36, so 226. Then all throughout, you're going to add 36. So plus 36, so 227. 226 plus 36, so 262. 262 plus 36, 298. Then 227 plus 36, so 263. Then 263 plus 36, 299. 298 plus 36, 334. 334 plus 36, 370. 299 plus 36, 335. 335 plus 36, 371. Then 370 plus 36, 406. And you might ask, when shall I stop adding 36? You stop in a class where the highest value is found. So we have 371 to 406. 371, the lower limit. 406 is the upper limit. And if you look at the maximum value, it's 405. So 405 is the maximum value. So we have in here, 405 is already found in this class interval, 371 to 406. So we stop in here because our maximum value, our highest, is already found in this interval, 371 to 406. So next is, we have there the upper limit. I discussed that one already on how to get the next lower limit and the next higher limit. So we have add the class weight of 36 to get the upper limit of the next class. So 190 plus 36 to 226. Then you add 36 to all and stop when you have that class where the highest value is found already. And it is in here, 371 to 406. So the next one, make a tally mark for each data entry in the row of the appropriate class. So if we go back to the data given, so these are the data given. So these are the data given. So you're going to tally, or you're going to tally. For example, 200. So 200, let's look at 200 belongs to this class. So 191 to 221, it contains 200. So we have one tally. Then we go back to the row data. So next is 239. We have the tallying by row, 239. So locate 239 in the different classes. So 239. So 239 is found in 227 to 262. So you're going to have another tally. So you are going to repeat the process until, so until all of these data are being tallied already to the classes that we have constructed. So you start from here, then by row up to this one, or you can start tallying by column, starting this one, then by column up to the last column. Then after that, so you have the tally column. So to get the frequency, count the number of tallies. So we have 3, we have 2, we have 5, we have 6, we have 7, we have 4, then we have 3. So the total is 30. Our summation of F is equal to 30. And take note that the total of the frequency column must be equal to the total number of data found in the given. So if you look at the given data, all of this data, so we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns times 3, 30. So the total number of data found in the data set and the total of the frequency column must be equal or must be the same. Okay, so we have now here the class, the tally, and then the frequency. Then determining the midpoints. So how are we going to calculate the midpoints? So the midpoints are actually lower class limit plus upper class limit divided by 2. So for the first one, 155 plus 190, then divided by 2, so we have 172.5. Okay, so take note of that. So can go back here. So we have 155 plus 190 divided by 2. 191 plus 226 divided by 2. So put and so on to 371 plus 406 divided by 2. That's how we're going to calculate the midpoint of a class or class midpoints. Then relative frequency of a class. So the relative frequency of the class, so portion or percentage of the data that falls in a particular class. So relative frequency is equal to class frequency divided by sample size is equal to small letter f divided by small letter n. Note that small letter n is equal to the summation of the frequencies. Then cumulative frequency of a class. The cumulative frequency of the class is actually the sum of the frequency for that class and all previous classes. The cumulative frequency of the last class is equal to the sample size, small letter n, or the total of the frequencies. So using the frequency distribution in previous example, find the midpoint, the relative frequency, and cumulative frequency of each class. Describe any patterns. So we have 155 to 190. This is the class, and this is the frequency. So to determine the midpoint, we have 155 plus 190 divided by 2, so 172.5. Then 191 plus 226 divided by 2, 208.5. Then 227 plus 262 divided by 2, so 244.5. 263 plus 298 divided by 2, 280.5. 299 plus 334 divided by 2, so 316.5. The relative frequency, that is 3 divided by 30. Where did we get 3? From the frequency. Where did we get 30? is the total of the frequency column, or the total frequencies, or the total number of data. Then we have 0.1. Then we have 2 divided by 30, so 0.07. 5 divided by 30, 0.17. 6 divided by 30, 0.2. 7 divided by 30. That will give you 0.23. And then take note that we use equality if the division is exact. We use approximation if the division is not exact. We rounded off the quotient, so we use approximation. So take note of that. And then cumulative frequency. So how do we get the cumulative frequency? So starting with the first, the frequency. So we have 3. And to get the next, so we have 3. Then, so we have 3 plus 2. So 5. Where did we get these 2? From the second frequency. Then 5 plus 5. So that will give you 10 as the cumulative frequency. Where did you get this 5? From the third frequency. Then 10 plus 6. So we have 10 plus 6 is equal to 16. Where did we get this 6? From this frequency. Then 16 plus 7. Where did we get 7? From this frequency. So we have 16 plus 7 will give you 23. Okay. So if you're going to have the overall frequency distribution, so we don't need to write anymore the tally, but instead we write the frequencies because the frequencies are equal to the number of tallies. So we have now the class, the frequency, the midpoint, the relative frequency, and then the cumulative frequency. So take note that the frequency column, the total is 30. That is equivalent to the total number of data found in the given. The relative frequency, the total must be 1 all throughout. The total of the relative frequency is equal to 1. And for the cumulative frequency, the last cumulative frequency is equal to the total number of data, which is also equal to the total frequency. So there are several patterns in the data set. For instance, the most common range for the expenses is 299 to 334. Also, but half of the expenses are less than 299. You can see that one in the table. Then we have frequency histogram. So data values, you can generate this one using Microsoft Excel. So frequency histogram. So how are we going to do that? So we have a bar graph that represents the frequency distribution. The horizontal scale is quantitative and measures the data values. The vertical scale measures the frequencies of the classes. Then consecutive bars must touch to each other. So you notice the consecutive bars are touching to each other. Then class boundaries. So how are we going to get the class boundaries? Because consecutive bars of a histogram must touch, bars must begin and end at class boundaries instead of class limits. The numbers that separate classes without forming gaps between them. So how are we going to do that? So we have here, draw a frequency histogram for the frequency distribution in the previous example. Describe any patterns. So we have the class, the frequency, the midpoint, the relative frequency, then the cumulative frequency. This is actually the given. And then we are going to modify that one. So constructing a frequency histogram. So we need only the class boundaries, and then the frequency. So if you look at there, how did we get 154.5? That is lower limit minus 0.5. How did we get 190.5? Upper limit, then plus 0.5. So 154.5, then 190.5. So if you notice, we only add 0.5 to the upper limits and we subtract 0.5 from the lower limits. So 191 minus 0.5, 190.5. 226 plus 0.5, so we have 226.5. And that is true to all. So up to 371 to 406, the class boundaries. 371 minus 0.5, so 370.5. Then 406 plus 0.5, so 406.5. And then copy again the frequency. So 3, 2, 5, 6, 7, 4, and then 3. So we have now, so you can mark the horizontal scale either at the midpoints or at the class boundaries. So both histograms are shown below. So let me move first this one para we can see that one clearly. So if you notice this broken axis would mean we go directly, no? We go directly to 172.5. But take note, the scaling of your x-axis and the scaling of your y-axis must be the same. When I say scaling, meaning the distance between one point to another point must be exactly the same. Not in that case nga, for one distance like this and the other distance is like this. The next one is like this. No, that's not the case. The distances must be the same all throughout. So if you look at both graphs, the distances are the same for x-axis and then the y-axis. So we have 1, 2, 3, 4, 5, 6. So we have the frequency, the number of adults, and this one would refer to, we have 172.5, 208.5, 244.5, 280.5, 316.5, 352.5, then 388.5. Then we have labeled with class boundaries. So we have 154.5, then 190.5, 226.5, 262.5, 298.5, 334.5, 370.5, then 406.5. So we have these histograms, no? Using this one is through the use of class boundaries and midpoints. This one for midpoints and this one for class boundaries. So when we say class boundaries, so this column, no, 154.5 to 190.5. And this 190.5 and this 190.5 are the same. So if you look at the graph, so we have 154.5, then 190.5. This 190.5 is common between the first and the second bar graph or histogram. And this one is actually the midpoint. How to get the midpoint? You are going to add 154.5 plus 190.5, then divided by 2. Or it can be also 155 plus 190 divided by 2. So you can add this 2 divided by 2 will give you the midpoint, or 154.5 plus 190.5 divided by 2 will give you the midpoint also. So we have here, you can see that 2/3 of the adults are paying more than 262.50 for out-of-pocket prescription medicine expenses. So look at some 2/3 of the adults. So you can estimate that on what is 2/3. So that's 2 divided by 3. Try to find out if you have that 2/3. Frequency polygon. So a line graph that emphasizes the continuous change in frequencies. So this one is an example of a line graph. So how are we going to construct a line graph? So draw a frequency polygon for the frequency distribution in previous example. Describe any patterns. So we have now class, so we have the class boundaries and then the frequencies. So to construct the frequency polygon, use the same horizontal and vertical scales that were used in the histogram labeled with class midpoints. So recall the first example. The graph should begin and end on the horizontal axis. So extend the left side to one class with before the first class midpoint, and extend the right side to one class with after the last class midpoint. So this one, 136.5. So in the previous one, we have 172.5, but we go down. So we have 136.5. The last one is 388.5, but we go forward, 424.5. That is what we mean by extend the left side to one class with before the first, that is 136.5, and extend the right side to one class with after the last class midpoint. So we have 388.5 increased by. And how to do it? 388.5 plus 36, because our class width is 36. And then you can actually use a computer like Microsoft Excel, depending on what gadget do you have in there. So you can exploit technology, especially Microsoft Excel. So you can see the frequency of adults increase up to an expense of 316.50, and then the frequency decreases. So it's here, no? Decreases. Relative frequency histogram has the same shape and the same horizontal scale as the corresponding frequency histogram. So data values and then relative frequency. So the vertical scale measures the relative frequencies, no, not frequencies, but relative frequencies. So still we have class boundaries, and then the frequency as the given. Then still the same kind of data. So we have now the relative frequencies, and then we have the expense in dollars. So we have 154.5, 190.5, 226.5, up to 406.5. And then take note about these values. So go back to the class boundaries, 154.5, 190.5, up to 406.5. So the last one is 406.5. So we use the class boundaries in here. And then from this graph, you can quickly see that 0.2 or 20% of the adults have expenses within 262.50 and 298.50. So you can verify that one in the graph. And we call this one as part of the interpretive exercise. So even if you go back here to this example, you can see that the frequency of adults increase up to an expense of 316.50, and then the frequency decreases. That is actually part of an interpretive exercise. Then going back to this claim in here, let's look at okay. So you can see that the frequency of adults increases up to an expense of 316.50, and then the frequency decreases. That is still part of the interpretive exercise. Remember that I mentioned about interpretive exercise, and you created your own interpretive exercise, and you created a video about that interpretive exercise. So as mentioned here, you can see that 2/3 of the adults are paying more than 262.50 for out-of-pocket prescription medicine expenses. This one is actually an example of an interpretive exercise. Looking at the data, you interpret the message of the data. You let the data speak. What is being told, what is being portrayed by the data. And that is actually part of the interpretive exercise. So we go to this top here. So we have here the frequency, the relative frequency. So we now go to cumulative frequency graph or ogive. So the ogive is referring to the cumulative frequency graph. So it's a line graph that displays the cumulative frequency of each class as at its upper class boundary. So what is being used in here is the upper class boundary. So the upper class boundaries are marked on the horizontal axis. So take note, the upper class boundaries are marked on the horizontal axis. So we have the y-axis, the cumulative frequency, and we have the data values found in the x-axis. But remember, we have the upper boundaries are marked on the horizontal or the x-axis. So cumulative frequency graph or ogive. So a line graph that displays cumulative frequency of each class as at its upper class boundary. The upper boundaries are marked on the horizontal axis. The cumulative frequencies are marked on the vertical axis or the y-axis. So construct a frequency distribution that includes cumulative frequencies as one of the columns and specify the horizontal and the vertical scales. The horizontal scale consists of the upper class boundaries. The vertical scale measures the cumulative frequencies. Then plot points that represent the upper class boundaries and their corresponding cumulative frequencies. Connect the points in order from left to right. The graph should start at the lower boundary of the first class. Cumulative frequency is 0 and should end at the upper boundary of the last class. Cumulative frequency is equal to the sample size or the total number of data. So we have here upper class boundary, the frequency, and then the cumulative frequency. So we have now 154.5, 190.5, up to 406.5. So if we go back to the data, so we have 406.5, then 190.5. But we have to go lower. So 190.5 minus 36 will give you 154.5 and up to 406.5. So all of these are upper class boundaries as being set in the guideline. And the y-axis is referring to the cumulative frequencies. So the cumulative frequencies, this one, 3, 5, 10, 16, 23, 27, and then 30. So if you are going to look at this is 0 and up to the highest one, the last cumulative frequency 30, that is equal to the total number of data or the sample size. Why we have this symbol? Because this indicates what? That we go directly to 154.5. We skip some of the values. So that's the meaning of this symbol. So from the ogive, you can see that 10 adults had expenses of 262.50 or less. Also, the greatest increase in cumulative frequency occurs between 298.50 and 334.50. So if you look at this kind of presentation, this is an example of an interpretive exercise, the one that I mentioned earlier in our class. Then we go to histogram and then making use of technology. So for the use of technology, because now we have some technologies, I'll give you the option what technology are you going to use. But mandatory, you're going to explore Microsoft Excel in your gadget and then generate the graph. So your assignment is actually to copy all of those and then do it manually. So copy exactly in there. In handwritten one, do it manually. And once you have done that one manually, you're going to generate that one using Microsoft Excel. So there are two submissions that you are going to do. So the handwritten copy of the contents of this video, handwritten in terms of those different things that we do in this video. And then the other one is a printout because all of those graphs there must be done in Microsoft Excel. So there are two submissions. The written one, copy all what you have in here. And then in terms of the graphs, you are going to generate that one through Microsoft Excel. So you can design that one as long as what you have generated in the Microsoft Excel is exactly the same to what we see in the contents of this graph, of this video, no? The graph in this video. So that's all. If you have some clarifications, you can see me in the office for consultation. So thank you very much.